So this is lesson 56, and we're going to talk about sets and also rearranging before graphing. So let's start with sets. There's two types of sets. The first type would be a finite set. So finite is the opposite of infinite. So a finite set, since it's the opposite of infinite, it means it has a limited amount of numbers in it. And so an example of a finite set would be something like this. And we enclose them in braces. So 6, 7, 8, 9. So this is a finite set because it only includes these four numbers. An infinite set, an example of an infinite set would be something like counting numbers. So we've learned about the set of counting numbers, which is 1, 2, 3, and then so on. So these three dots indicate that it goes on forever, right? So it's an infinite set. So we're mostly going to deal with finite sets today. So if we have, let's do an example. If we have these numbers 0, 3, 0, -3, 2, 0, 3, 9. So this is a set of numbers, and if I wanted to explain that it's in a set called set L, then I would say L equals, and then I would use the braces, and I would just list the numbers. And I don't have to repeat the list. If there's a 0 3 times, I only have to write it one time. And I also don't have to write it in order. So I got my zeros, I got 3s, -3, and 9. So it doesn't matter which order they're in, but you only have to write each number one time. So set L equals these four numbers, and some of these numbers could be repeated like we saw here. So that's how you designate membership in a set. Now the next thing we're going to talk about is like symbols that we use when we talk about sets. So let's do another example. Let's say I have three sets. I have set A equals 0, 1, 4, -2. And I could say set B equals 3, 5, 4, 9. And then set C is 1, 3, 5, 7, 9. So I have these three sets, and I could say some statements about these sets. For example, I see that the number -2 is a part of set A. It belongs to set A. And so if I want to write that, I would just go, okay, -2 belongs to this symbol. It looks like a funny E, but it means belongs to. It means -2 belongs to set A. I can also say -2 does not belong to, -2 does not belong to set B. So I could cross out the symbol, and that negates the symbol, or it says the opposite of what the symbol says. And so let's do a couple examples. We're going to determine if these are true or false. So for example A, I could say 3 belongs to A. Is that true? Is 3 a part of set A? No, so this would be false. Let's see, example B, I could say 4 belongs to B. 4 belongs to set B. Is that true? Yeah, it is true. Another example, I could say 9 does not belong to C. Does not belong to. So I'm going to cross it out. Is that true or false? Well, 9 does belong to C, so this would be a false statement. And then finally, I could say 7 belongs to A. Well, I look at A and there's no 7 there, so this is another false statement. So basically, it's just these symbols. So that's really all we have to talk about with sets, is just learning the notation, learning the brackets or the braces, and learning the symbols. And so basically that's it for that, but we still need to talk about the other topic of lesson 56, which is rearranging before graphing. So let's talk about that. So rearranging before graphing, if I have an equation like 3x plus 2y equals 4, and I want to graph it. So the way that we've learned to graph things is by creating an x and y table of values where we choose different values that are convenient for x, and then we evaluate the value at y. And so, but before we do that, the first thing we need to do is rearrange. We need to rearrange this equation by solving for y, by isolating the y variable. So in order to do that, I would need to move this 3x by subtracting 3x from both sides. And then I would cancel from here, and I would get 2y equals negative 3x and then positive 4. And then further isolating the variable, I need to divide both sides by 2. And then I get y equals negative 3x, or negative 3 over 2x plus 4 over 2 is 2. Okay, so now that I've rearranged it, I can go ahead and pick convenient values of x and plug them in to figure out y. So the most convenient value is usually 0. If x equals 0, y equals 2. So I could graph that on my coordinate plane here, 0, 2. What else? I want to pick another convenient value. And since this is a fraction with a denominator of 2, and if I want to cancel out that fraction, it's good to use things, multiples of 2, so I can cancel the fraction. Because fractions are kind of annoying to graph because we don't have like 1/2 marks and things like that. So let's go ahead and say let x equal 2. So let's see, if x is equal to 2, then y would be equal to negative 3/2 times 2 plus 2. These 2's would cancel, and I'd have negative 3 plus 2, which is negative 1. So then I can plot that point. Positive 2 in the x direction, negative 1 in the y direction. Okay. Let's do maybe one more value. So another convenient value would be negative 2. If I plug in negative 2, I have 3 over 2 times negative 2 plus 2. Again, the 2's cancel out, but this time it's going to become positive. So this is positive 3 plus 2, which is 5. So my ordered pair is negative 2, 5. So if I go negative 2 in the x direction and up 1, 2, 3, 4, 5 here. And then I can go ahead and connect my points to make a line. And so that's it for lesson 56.